another area that I'm really fond of. Part of my former NASA career, I funded some of the space weather efforts. So I'm really interested in what they have to say, because our ability to, as humans to extend beyond the Earth's atmosphere are dependent upon our abilities to understand the environment in which we're entering. And so I'll turn it over to Antti Pulkkinen, who's the Director of Heliophysics Science Division here and at Goddard, and I look forward to the results of your panel. Take it away.
Thank you so much. Okay, let's see if we can go to the next slide here. Does this clicker work? Do I need to point this somewhere? Oh, there you go. Okay, thank you. Thank you again. So my name is Antti Pulkkinen. I'm the Director for Heliophysics Science Division at NASA Goddard Space Flight Center, and the theme of our panel here this afternoon is Space Weather 2040. And we have a number of distinguished panelists here who are some key leadership in the space weather field here in the US. We have Nicole Duncan, who's a strategic planning manager for civil space and mission systems at BAE Systems Incorporated, formerly Ball Aerospace. We have also Lieutenant Colonel Omar Nava, who's the chief for space weather and environmental EM effects, weather strategic plans and integration division at U.S. Air Force Weather. We also have Mangala Sharma here, who's the program director for space weather at the U.S. National Science Foundation. And then also we have Elsaid Talat, who's the director for the Office of Space Weather Observations under the NOAA NESTIS. So really a distinguished panel here. Looking forward to the discussions. For those who are not too familiar with the space weather, just kind of a quick, very top level overview. What is it that we are all about? Space weather is really, you would say, a branch of heliophysics. In heliophysics, we study the sun. We study how the flows coming from the sun interact with the interplanetary space, and ultimately how these flows also interact with the planetary magnetospheres and planetary upper atmospheres. In heliophysics, we ask questions such as why and how does the sun vary? How do the planetary environments respond? And then we also ask the all-important societal questions such as what are the implications for life and society? And it's that life and society piece that we really call space weather. And space weather does have an influence, as we will talk much more within this panel, on our infrastructure, both in space and on the ground, and also can impact humans in space. For the panel, we agreed that we will address one quick prompt here. What is your vision for Space Weather 2040? And what steps are needed to take us there? Each panelist will have 1 or 2 slides. We agreed to have about 5 minutes of introduction here, and then we will have plenty of discussion and Q&A with the audience here. So we're really hoping, and following Mackenzie's prompt here, is that we keep this as a conversation between the panel and the audience members here in the room. I would be remiss not to advertise before we jump into the panelists here. Heliophysics Big Year. Heliophysics Big Year is a celebration of the exciting science of heliophysics, and also celebration of the importance of space weather. Heliophysics Big Year is a collection of major events taking place. We kicked in the year with the annular solar eclipse that took place October last year. Next major event will be the total solar eclipse, April 8, and hopefully all of you have heard about April 8. So who all have plans for April 8 to see the total solar eclipse? I want to see everybody's hand, okay? All right, there you go. If you are not going to the path of totality, don't panic. Even here in the DC area, you will have a pretty good coverage. We would have about 80% partial solar eclipse taking place. Still very fun event to observe. Always keep in mind that the eye safety is important. You should not be watching or looking at the solar disk without those solar eclipse glasses. Okay, so make sure to take your pair on your way out here. There was a table out there in the foyer where you can collect your piece of eclipse glasses. It is safe to watch the sun only during the totality itself. So if you're in the path of totality and the moon blocks the whole solar disk, then it's safe to remove the glasses and observe the beautiful solar corona, solar atmosphere. So with that, we'll dive right in and see I think our slides might be in random order, so we'll see who's the next one. All right. So I think, Nicole, you're up first.
All right, thank you, Auntie. Thank you to the organizers and the sponsors for bringing us here today to have all of these very important discussions. So I'm going to talk about my vision for space weather in 2040 and probably a little bit beyond that as well. There are 5 different aspects I want to talk about, which are listed here. So to start with, in 2040, I think our society will have internalized the importance and relevance of space weather. And this will come in the form of continued public policy, because as our technology evolves, our society and our policy needs to evolve with it. So we have great bedrock for that in ProSwift. That's very exciting. We got that a few years ago, but that needs to be updated. I doubt it'll be able to deal with things like a thriving lunar economy that we talked about earlier today. And in my notes, I wrote that maybe a thriving lunar economy in 15 years might be far-fetched, but given the discussion earlier today, maybe not. And 15 years ago, I think a lot of people would have thought that the proliferation of mega constellations in Leo that we have today, that might have been far-fetched too. So the bottom line is that as society grows in new and different ways, and all of us are contributing to that, our policy needs to grow. And we might not accomplish this by 2040, but we'll know that we've arrived there when new space weather impacted sectors are coming and self-identifying to us. And we don't have to do the same type of outreach that we do today in order to identify those new communities. So societal wisdom is really underpinned by scientific understanding. And the aggressive pursuit of scientific understanding of space weather is important to our society because it depends, or it influences, our ability to create deployable knowledge, actionable information, and streamlined data. So as our systems grow in magnitude, I mean, we talked about a large infrastructure that is being planned for in outer space. And even here on Earth, as our systems increase in magnitude, as the demand for precision within our systems increases, we're going to need to more fully understand the underlying science in order to understand the impacts and create deployable knowledge from those. And by this, I mean things like really understanding cascading failure scenarios and being able to fully scope things like economic impact assessments. So in 2040, I would love to see that we fully understand the cascading impact scenarios. Every emergency manager has that knowledge and the tools that they need to deal with it on Earth and in space. And that in 2040, we use those very fully scoped economic impact assessments to determine what types of resources we're putting towards space weather. So moving on to actionable information, the perplexing thing about information is that too much of it can actually paralyze a system or a manager. So I would really like to see that in 2040, we have a very good understanding of what information we actually need, and that we are working with the community so that way we don't need super users and experts across all of our user communities to be able to use that data. I would love to see the fact that across our user communities, that maybe it's an educated user, not a super user, who can actually take that information and use it to make decisions. And finally, talking about streamlined data. So there's an adage that the better that we know a system, the fewer variables that we need in order to really describe it. So El-Sayed will show us the vision for the operational data in 2040. And there's a lot of opinions about what additional data will be needed to support society as we grow, or even as we want to get better in our ability to predict. And so what I'd really like to see in 2040 is that our scientific understanding has advanced to the point where the community has converged on what they think we actually need. Because right now, a lot of those opinions are conflicting. There's a lot of different ones of them. And we really need to be concise in the types of data that we're collecting, because that's impacted by budgets. We're not going to have the ability to collect everything. Thank you.
Thank you, Nicole. And then let's see, who's that? That's Omar, you? Okay.
All right, good afternoon, everyone. I guess I took a little different approach to this question. But before I begin, thanks again to the Symposium organizers for inviting me to participate again this year. So last year was a lot of fun, and glad to participate again. So in short, my vision for Space Weather 2040 is a national space weather enterprise, as well as a society that is resilient to the sun's adverse effects on Earth and in space. So basic definition of resiliency is, the ability to essentially take a punch and, keep going, not only from large 100-year significant events, but as well as everyday events that affect different aspects of society, operations, et cetera. And so you hear the term resiliency, and not only in the space weather context, but also in sports, competition, systems for you engineers out there, and as well as personal, well-being. But from a military and national security perspective, to me, basically, capabilities such as GPS must be available when you need it for navigation. Same thing applies to radio and satellite communications, or even making sure that your satellites are up there and working properly and hardened against radiation. And especially in 2040, if we have, folks heading towards Mars and coming back, you want to make sure you have those capabilities available. So what steps are needed for us to get there? So I wanted to touch on 4 things here quickly. So anticipate, prevent, respond, recover, and adapt. So first, anticipate. I mean, you have to know what's coming, when it's going to get here, and how bad it's going to be in terms, in this case, solar events. And so, we do have some observations, we do have some models, but we need more. And I'm pretty sure that's going to be a common theme through this panel. And including even a better understanding of the science. So really pushing the envelope of the state of the science at the moment. Next, prevent. I'm sure a lot of folks in this room are familiar with this, but includes hardening of satellites against radiation, as well as space vehicles, basically resource protection in general. And so, you could argue, well, if a satellite's sufficiently hardened, then space weather doesn't matter. That's one particular approach. But some components of the satellite, not a satellite person, but some components are still susceptible to the space environment. So you got radio frequency interference, satellite communications, disruptions of that aspect that are due to the environment. How do you deal with that? And so thirdly, respond and recover. And so I like this image here. I'm not sure if folks remember, but in July 2019, there was a blackout in New York City. Basically lasted from about 6 hours into the evening. 72,000 customers were in the dark. And I pulled up this quote from then Governor Andrew Cuomo. He praised the emergency officials for the response, but he basically said, you just can't have a power outage of this magnitude in this city. It's too dangerous. The potential for public safety risk and chaos is too high. We can't have a system that does that. It's just just that simple at the end of the day. And so this was, it was a power issue, and they were able to resolve it fairly quickly. But one of the big concerns of a, say, 100-year space weather event is effects to the power grid, possibly, parts of the country not having power for a significant amount of time. So, sort of not that difficult to imagine, instead of just a few hours, what if it was days, weeks? What if it was more global and not just New York City? And, sort of my notes here, what kind of Lord of the Flies chaos would come about from that? So that's a huge concern. And then lastly, adapt. And I think Nicole touched upon this as well, but I like this quote by Dwight D. Eisenhower. It said basically, plans are useless, but planning is indispensable. And so 2040, still years away, 15 years away or so. Actually, it's not that far away. But we don't exactly know what the space weather enterprise will look like and what society will look like. What do we do when funding is scarce, or even more scarce than it is today? What if priorities change? What if technologies and capabilities are not maturing as quickly as we thought? We still need to be able to thrive and make those tough decisions. And one thing I wanted to point out, and speaking of the budget, since it's a big concern this week, but some things, of course, can be solved with more money. If there's a mature capability that's ready for operations, additional funds can help to get that over the finish line and into ops, and that's good. And NASA's doing a lot of that work currently. But then some things can't be solved with necessarily more money. For example, how do you train the next generation workforce? How do you get more folks interested and invested in the space weather enterprise? even advancing the state of the science. So, if you had $1 billion right at your fingertips, could do you know enough to be able to forecast solar flares and CMEs, coronal mass ejections 7 days out? I don't think we're there yet, but that's definitely something where we need to be. So in conclusion, I wanted to note on this slide here that there are no organizational logos or symbols on this slide. And so we, to include government, academia, industry, we really do have to work together to ensure that we have a space weather resilient nation, especially in 2040. So thank you.
Thank you, Amar. Okay, let's see. Mangala.
Good afternoon. My name is Mangala Sharma, and I just want to say thank you very much to the organizers and to you all and my colleagues here. This is going to be a fun discussion. And we talked about the solar eclipse, and I wish we had one of those coronagraphs right now so I could block the sun that's shining directly at us. But I wanted to ask a question here. How many of you have seen the aurora, borealis or australis? Cool. How many would like to see it? There, see? You see, you're all space weather users right now, right? Because auroras are a manifestation of space weather. And so aurora tourism is becoming a big thing, right? So how many of you would like to go into space? We talked about the cislunar economy this morning. How many would like to go? Me too. Yeah. How many have gone to space already? Got to bring those people in here. Yeah. So look, this is where I think, and I've said this many, many times, space weather is a team sport. We are all in this. We all want to be in this. We all need to be aware. Nicole and Omar have already talked about, the amount of science we need to do in order to understand space weather, the amount of adaptation we need to be thinking about in order to do space weather. So here is my tagline for space weather in 2040, right? No eruption unobserved, no impact unrecorded. We need to observe every single thing we can about every single driver of space weather. Auntie talked about the sun being the driver, one of the major drivers of space weather. But only in the past decade or so, we've understood how much the lower Earth atmosphere, how much things like hurricanes and volcanoes and earthquakes can actually travel up. That energy can travel up all the way into the upper atmosphere and create space weather in near Earth space, right? This is so cool. This is the sort of science we need, the system of systems thinking. And that is where the research comes in, because there's so much that we don't know yet. There's so much that we don't know about the drivers of space weather, the complete set of cascading phenomenon that lead to one event leading to another. And we don't yet know about all of the impacts, because some of those impacts, they are scary stuff and they are business sensitive information. But at some point, if you don't understand what the impacts are, you can't build the adaptations and the resilience. So I'm looking for a time in a few years, a few decades from now, where the users of space weather are able to share that impact. So it's not just ubiquitous observations, but ubiquitous knowledge of the impacts so that we can prevent certain bad things happening again and again and again. We need the research infrastructure, no eruption unobserved. We need research infrastructure everywhere. And that research infrastructure, the observations, can come from anyone, right? Fitbits were used to figure out there was an earthquake somewhere. What kind of citizen science, what kind of crowdsourcing information, what kind of information do we have on us that could be useful for space weather? Not just the big research facilities which we are building, which are absolutely essential, but what else is there that we are not tapping into? And that's the sort of thing that I would love for us to talk about and think about. And of course, we've all mentioned this. And we talked about this in the previous session. In order to use all of this data, in order to understand all of these things, we need the people. We need new skills. We need to be able to employ the full spectrum of experiences and expertise and vision and risk-taking that is needed to make a change. It's exactly as Omar said, I have logos. Yes, I do have logos, but it is really a team sport. We all work together. We work together across the government. We will work together across the commercial sector with the people. This is where I think space weather becomes important. It is a unifier. It happens at all scales, right? It's a global phenomenon, but it has local impacts. And so what do we know about these things? What is still to be known? And I think that excitement unites us all. And so I'm looking forward to the rest of the conversations we're going to have. Thank you.
Thank you, Mangala. Thank you. Let's see. Hopefully next one is you, Elsa.
I hope so.
Let's see. Is this yours?
Yes.
Okay.
Thank
good.
you. Yeah, being last, I get to say what they said. And then and I'll add a few other things. So this is a picture here. I'm not sure why the NASA logo is on there, but but it's supposed to be the whole space weather enterprise, what we use for operations. So it's both ground-based and space-based. And currently, right now, this is a very fragile system, both on the ground and in space. We're using aging observatories that are well past their design lifetime, and in some cases we don't have a plan yet for how to replace them. So the vision for 2040 is that we have a sustained effort, starting with what we're doing in space with SWIFO and Space Weather Next, and in the ground with Next Generation Gong, to build up a resilient infrastructure for space weather observations. But this also shows that these observations that are coming in, they're used, as what was said earlier, for actionable information for our stakeholders. But we're in a situation where we're data poor, space is big, and we need different vantage points. We're data poor, but we're at the same time, we're not fully utilizing the observations we have. We're not taking advantage, not exploiting them fully, because we don't have the sustained research and development for data assimilation in ionospheric, thermospheric models, and other model development, such that we can fully exploit the data we have. And so in the, oh, wrong way. Yes, you told me that. Down is up. Yeah, down is forward. So for the 2040, we see this, of course, as a planetary system observing challenge. We are right now going to fly to L1, and we're going to partner with ESA to fly to L5 and give us stereo observations of the sun. But we really need to have the AU ring, similar to what we have in terrestrial weather with a geostationary ring, where all the nations, the meteorological agencies around the world have stationed geostationary satellites, and they share that data to get full 4-pi context of what's happening on Earth, with the low Earth orbit doing the poles as well. And we need to do the same thing at the sun. So the vision in 2040 is that we'd also start by having the Lagrange 4-point measurements as well. And that'll get us pretty far along to full coverage of solar activity. And at the same time, we do the necessary science missions that will advance our capability in low Earth orbit, using the measurements in low Earth orbit to advance our capability for ionospheric thermosphere prediction. And we're advancing we're improving our latency with sub-L1 observations. So that is a direct, that is really the technology that is right now the most promising for us to get us the longer lead time that we need for the power grid, civil aviation, et cetera. So that upstream buoy that we have at L1, we want to get it further in toward the sun so that we can give us a faster warning. And then looking further for the Mars exploration and cislunar exploration, cislunar development and Mars exploration, we need to think about what the observing structure needs to be to support human exploration around the solar system. And that's beyond the solar ring, that AU ring. We have to think about, well, the vision would be that in 2040, we're putting in place a Mars L1 observation. So that gives it the upstream buoy at Mars to warn of any incoming dangerous solar radiation there. That's it.
Thank you, Elsa. So now we will be moving to a Q&A session. So we'll have a good 30 minutes here to just have a discussion with the audience in the room. With the powers of the chair and the moderator, I shall take the first question and then open up the floor for everybody else. Sort of building on Elsa's points that by 2040 we need to be able to establish robust operational observational network for space weather. I guess, also passing to Elsa, but certainly for the other panel members here as well. In your mind, what is the most significant space weather gap in terms of our capabilities we have right now? And how do we move toward patching that gap by 2040? So Elsa, go ahead and
So I'll take it from both an observational point of view and a modeling point of view. The significant gap we have is having different vantage points around the solar system. So being able to view it from L1, view the sun from the sun-Earth line at L1 and geostationary, and then adding L5 is going to be a huge capability enhancement. But we also need to have an additional vantage points, and L4 is the next promising vantage point there. And at the same time, there's also a big need for observations at Earth as well. So understanding the ionosphere-thermosphere system and the interaction of those inputs from the sun and how they interact with the upper atmosphere and ionosphere here is absolutely huge. And so we need the measurements, the in situ measurements from constellation of satellites at low Earth orbit, as well as the suite of measurements that we would need to understand the magnetosphere ionosphere interaction going there. And so those are the biggest gaps. That's how we can advance the models with that data. But on the modeling side, the biggest gap is data assimilation. We do not have sufficient data assimilation in the models. And that's cries out for a sustained effort and a whole community effort from the research agencies as well as the operational agencies to put the resources in and the planning in to ensure that in 2040 we're fully utilizing the data that we get, for instance, from radio occultation that we're purchasing as well as flying on government satellites.
Thank you, Elsa. Nicole?
So, of course, I agree with everything Elsa had said, as is the theme for this panel. But I think there's a lot of scientific understanding that we still need to have here. One of my last points was that as you better understand a system, the fewer variables you need to constrain it. And so, for example, one of the things that I hear a lot from observers is not having the access to the polar fields. And so that's a gap that I personally think needs to be filled. We need to have the scientific understanding as to if that really is a gap that needs to be included in the architecture.
Thank you. Omar?
So from my point of view, first thing that popped in my head was, in terms of most significant space weather gap, is really learning, at least improving how we work together. I think it's still sort of new. The Space Weather Operations Research Mitigation Interagency Working Group basically tasked the agencies to collaborate on research, sharing observations, et cetera. And so I think we're still trying to figure out efficient ways to do that. And even within the Department of the Air Force, we have the Space Force now, in addition to the Air Force, and we're still trying to figure out that aspect too. But but I think that'll basically solve itself in time. I think we have basically the right groups we interact with each other regularly. And so I think that'll solve each other in time, but that can be one component that can help a lot of the observation gaps, modeling gaps. One agency doesn't have to do everything on their own. We'll cooperate and graduate type of thing. So.
Thank you, Omar. Angela?
I'm going to say what else I had said, ditto, ditto, ditto. I also think that, having this holistic understanding of space weather, like we said, right, it's a global phenomenon, global, local, mesoscale phenomena at different intensities, everyday and extreme, over what duration, right? Instantaneous versus things that space climate need to be studied. And I think this is where the gaps are in dealing with like a theory of everything of space weather, right? So that's a huge gap. It's not something we can do today or tomorrow, but if we don't reach for the stars, keeping our feet on the ground, but if we don't reach for the stars, we are not going to reach for the stars. So I think that having this big picture, holistic understanding, the systems of systems thinking, of understanding how different impacts cascade onto each other, that to me is a very, very significant gap. It's not going to be filled tomorrow. It's not going to be filled the day after tomorrow, but we need to identify it.
Thank you. Thank you very much. So let's go to the audience questions. Mackenzie.
Thanks. So El-Sayed, you mentioned the data assimilation as being a big gap, and that's something where theoretically we could make a lot of progress on near term. It's not a long space project. It's not technologically a barrier. So can you talk more about why and how you see maybe that being that bridged?
I agree. It is not. It is something that we should be able to tackle very near term. And why is kind of a historical issue in the sense that if we look at the analog with or analogy with terrestrial weather, we had sustained development in the operational agencies in DoD and at NOAA for different aspects that are for different modeling that was done in terrestrial weather that took advantage and worked very closely with the research agencies. So you had modeling centers at NASA feeding into modeling centers at NOAA, feeding into modeling centers at NSF, et cetera. But it was a priority in terrestrial weather for the operational agencies to do that sustained development because they had their own specific needs that drove the topics and the applications that they put forth. Historically, space weather, we've relied on the operational agencies have relied on the research agencies to make those advancements, and they have. So we've had research to operations. We've transitioned models from the research agencies, the ENLO model, geospace. Everything's come from not research agencies, research communities, research communities. But this is at a very slow pace, similar to what we're doing in observations. It took us nearly 30 years to fly an operational coronagraph. We're going to in a few months. and similarly with models, it took us decades to get the first models out. And now how do we advance them? And we need to develop, and this is what the Space Weather Advisory Group identified as a gap, and then SWARM also identified as a gap. Need to develop a dedicated research and development effort at NOAA. Specifically, and for space weather, and that is not to say that it actually will be able to take advantage of what this research efforts are in the community are happening. So it's that catcher's mitt that we've all heard about. We don't have that catcher's mitt. We have the two ends at NOAA. We have the observations and we have the forecasting center. We don't have the catcher's mitt for the development that can take what the research community is doing and apply it and then feed back to the research community, that operations to research effort. as well.
Thank you, Elsa. Anybody else in the panel want to comment?
If I may.
Go ahead, Michael.
Yeah, and Mackenzie, this goes back to what you spoke about earlier today about using AI, ML, et cetera, right? So sometimes there's a lack of data, sometimes there's disparate data, but there's definitely data. And as Elsa had said, how can we best utilize it? And sometimes that means we need to develop some tools. There are tools, but are they the right tools for this job, right? So it's also about, identifying what makes sense, considering that there is a legacy of models, a legacy of the way of working in terms of space weather research, in terms of space weather operations, and in terms of space weather applications. So how do we work together? And this goes back to what I think Omar brought up, right? It's not one agency, one area of doing things. It is about figuring out what exists, what needs to be done, and how to leverage the tools we are building and build new tools as necessary. None of those is an easy thing, of course. But again, this is the sort of thing, I think we're taking baby steps towards it. And I think we just, we just have to kind of feed and care for the baby. So.
Yeah, I think there's also an aspect of, what Mangala just said about the workforce and workforce development to this as well. We have people who are trained as scientists, operators, not necessarily in the technical aspects of modeling and all of the computer science that nearly needs to go into that. And so actually another one of the findings of the SWAG was this gap in knowledge and training and also of workforce development. Making sure that people who do have those skill sets that don't necessarily have the scientific background have a career path within these communities and that they're able to thrive here as well so that we can bring those tools and that expertise into our different types of modeling efforts.
Thank you. Next question, there in the corner, please. There in the front, do we have a mic? And if you please don't mind introducing yourself, a name, title, and the organization.
Myra Montrose, I'm with L3 Harris, and my question is a continuation of this discussion with the international point of view. So for example, for regular weather, we have the European models, we have the US models. What's your vision for 2040 for bringing space weather models together? Like what's the contributions of the international community? How are you working with them now to look forward?
Who wants to go first? Omar?
Okay, well, actually this is sort of fortuitous timing. So on the military side, NATO actually just stood up a new military space weather panel. So, buy-in from 31, 32 countries now. And there's actually a meeting at Supreme Headquarters, Allied Powers Europe in Mons, Belgium next week that I'm hoping to go to, assuming I have travel funds at the end of this week. But this is but it really is a great opportunity to leverage other nations' capabilities and from a military perspective, they're scientists, they're experts. A lot of them come from meteorology and have been sort of put into a space weather role. But it's actually been really great, especially in my position here, to really try to form something from the ground up in collaboration with these other countries. And so I know UK's a lot of capabilities that they bring to the table. Germany as well, and I'm not going to be able to name everybody, and I don't want to offend any other nations. But it's really good to see a lot of the concerns that that the Swarm IWG is trying to address here in the United States. Also in the international stage, how do you workforce development, new models? How do you transition those capabilities into a shared space with NATO in a joint environment? So it's a lot of challenges there and a lot of parallels with what seeing in the U.S. So, but to answer your question, progress is being made, and definitely value the other countries' contributions.
So I would say that this is something that's been actively pursued also from a science standpoint through the COSPAR, Committee on Space Physics and Research. Forget the acronym, but they've started this effort for really advancing space weather applications, different space weather applications and technology, including modeling. It's called ISWAT. Again, I don't remember the acronym, but that's an ongoing effort right now. And then from kind of an operational standpoint, I'm not only banging on NOAA about data assimilation, but also the other agencies that provide data and also run models like EUMETSAT, European Space Agency, and the International Space Environment Services, which is the space weather centers around the world. They collaborate again slowly on different data sharing and model development, and so it's really the international fora are really just starting, but they haven't caught a lot of momentum yet. Or I should say, they have momentum. They haven't been going very far yet.
Thank you. Nicole or Mangala, any comments on the international dimension?
So I guess I don't have a comment on international in general, or particularly, but on collaboration in general. I think it's going really well right now. So there's a lot of different activities going on. I mean, of course, we're hearing from the agencies here. I'm from industry. We have a lot of ties to academia, and really that collaboration between industry, government, and academia, I think, is really valuable for the space weather enterprise. It's absolutely vital, right? I mean, as we talked about the research to operations pipeline, the reasons why science is so important to us as a society and our progress. And it's, there's a lot of goodness that came from the Pro-SWIFT Act and really starting to establish and lay down what a lot of those roles and responsibilities were and how we could collaborate together as well. So one thing that Pro-SWIFT did is it established different types of advisory groups. And this is one of the ways in which I think that there's been a lot of success recently in the space weather enterprise, making sure that there's a lot of opinions that are being, considered and brought in. There's a lot of very specific membership in those. So for example, the SWAG, which Elsie had mentioned, and I happen to be on, is very specifically industry, academia, and government as an advisory body to the NSTC SWARM, Space Weather Operations and Research Mitigation. Thank you. And so it's just been a really inspiring time, I think, to see everybody coming together. I'm just really excited to see what we're able to accomplish in the next 15 years as we move towards 2040.
Okay, all right, so let's take a next question. Let's take something in the back. I can't see people there. There's ma'am there in the back, in the middle, yeah. Again, name, title, organization, if you don't mind.
Hi, my name's Allie Halleck. I am at Northrop Grumman as a radiation and survivability engineer. And my question for you guys is, what do you guys see as plans for 2040 in space weather, and how to do a little bit more integration and making space weather more interdisciplinary so that data is being used not just for other scientists and other data scientists, but also integrating into engineering and impact, so it's used across industry for more than just science, but how is it affecting satellites? How is it affecting power grids? How is it affecting other industries that are not just specifically in the how do we get more data field, and how do you see carrying and sharing that data amongst, like we were talking about before, international lines and within industry?
Thank you. Nicole?
So I can start. So I think the first step in that is understanding who those users are and what those users need. Right? So turning data into actionable information that will change and something that they might do in response to or in reaction from space weather. And so that's one of the activities that actually was outlined in ProSwift, was to do a user needs assessment, which the SWAG is currently undertaking and will be released at the Space Weather Workshop here in about a month. So, you know, and there's been other reports and other pieces of information that preceded this as well that went into the nation's response to this. But this was, you know, a large part of the point that I was trying to make in my earlier vision, is that, you know, that integration with the user community, so that way they do not need to be experts or even super users of that information in order to make actionable decisions.
Thanks, Nicole. That's it.
I guess I would say part of our, I think all of our collective 2040 vision is that the need is going to be greater for space weather in 2040 than it is now. We talked about the mega constellations and how that's changing the game in terms of what we need to understand about the upper atmosphere and the thermosphere and ionosphere, and then exploration is going to drive the need for space weather more. And so you know, one thing we can envision is that space weather, you know, we're not, the end user doesn't care about what the particle environment is. They care about if there's a danger to their assets or there's an error in their operations. And so we can envision a space weather being a forecast that's along terrestrial weather. You check every day before you go out. I did. Got it wrong. I shouldn't say I'm Noah. I got it wrong, I should say. Not Noah got it wrong. And it was cold this morning. I brought a big coat. You check every day before you go out. And it's the same thing where we do have users that do check every day the warnings and forecasts. And they also, if you go to launch services, they have space weather on the monitor. I think that the vision would be that this would be expanded to all the end users, not looking at data specifically, but looking at getting a forecast and warnings, as Nicole said, understanding how tailored to their needs rather than our presentation. So,
Mangala, go ahead.
No,
So one thing I wanted to add on, I think, is the flip side to, you know, educating our own workforce and developing our own workforce, but it's also educating up. So educating, you know, decision makers, policy folks, you know, making other people who aren't space weather scientists, you know, care about these impacts, and you know, that can trickle down to other aspects of society. And so one example I'd like to use is, you know, we hear weather all the time, terrestrial weather all the time. If you know there's a Category 5 hurricane headed towards Miami, you know that's going to be a bad day. But if, you know, there's a fast-moving CME with a large negative BZ, some of you may understand that's probably not a good thing, and other people may not necessarily know. But I think it's just really educating the public, educating decision makers, policymakers, you know, folks who control, you know, who influence budgets, that, you know, space weather is important, and it's not going to go away. And so, you know, then another effort is really just trying to educate those folks who, you know, just space weather is just something they just sort of hear on the fringes, and so that's a challenge, and definitely something we need to work towards as well.
actually, Omar kind of preempted what I was going to say, and that is, you know, the best thing we can prove by understanding space weather is that there is no catastrophic impact. So how do you convince somebody by that an absence of something is a good thing, right? And that's one of the nicest challenges we have, actually. And so I'm actually going to ask a moderator to speak a little bit about some of his work. He's been working with the power companies and understanding what are called ground-induced currents. So I would actually like to hear from him as well, what he thinks are ways of understanding data and impacts and moving it across sectors.
Well, thank you for tossing it this way, Manuel. So I think, you know, from my standpoint, the capability to communicate between the researchers, operators, and the end users is absolutely critical. So talking to your integration piece here, And Mangala mentioned that I've been doing quite a bit work in the power grid context, impact on the power grids, across the globe. And one of the things that we were able to establish here in the U.S. Just a few years back is we have now standards. We have a regulatory framework in place that was ordered through Federal Energy Regulatory Commission. And key part of that work was that we were able to establish common language between the scientists and the power engineers and the end users. We were able to establish what is the interface where we exchange information and what is the information that we're exchanging. And that got really the wheel spinning. So we were able to do a lot of the hazard assessments and the impact on the power grid. And those hazard assessments are also part of the regulatory framework. So in terms of a across-the-board integration, establishing, getting the key people in the same room, that's the step number one. And then working to establish that common language. That's absolutely critical for us to be able to make progress on this. So thanks, Mangala. All right, so next, okay, Mackenzie.
Just a follow-up. So what about the actual decisions that people take to mitigate the impacts? I mean, are you finding that people know what they need to do? Because some of these might not be sophisticated users, depending on where they are in the world or what sector they're in. So how do we bridge the gap between, okay, this is the potential impact, but now what do you actually do about it?
Yeah, I can just quickly mention from the power grid context, since I was already talking about that. One key part of the regulatory framework is that there needs to be an operational plan in every operational room in the US if you're operating 200 kV system or above. So that requires that the individual utilities have to do a certain level of training of their operational personnel so they understand what those A through Z's mean when the storm hits. So there's an absolutely significant educational piece to this. And to me, that part of the education is to establish that common language, right? And getting people together, talking about these issues, and making each other understand what are some of the key challenges that we're tackling with. At the end of the day, you need to have something in the books, and you need to come with the training that is commensurate what is in the books.
Yeah.
Elsa, please.
Just to add to that, that's why we establish a tight relationship with the different stakeholders we have. The power grid is one of them. Civil aviation is another. National security, space is another one. And we have that aspect of education and feedback. And then one thing that we're all participating in is these test beds that SWIP's Space Weather Prediction Center is leading, where it brings in our agencies are part of the board, or a board of, and then participate in that, but also brings in industry and the operators and then have that interaction about what service they're getting, what they want to get, what's the barriers for communication, and what's the barriers for action, for decisions. What would they like to see in the future so they can make the decisions that they want to make? And I think just to add on to what Mangala said is that if from a holistic point of view, or from a community point of view, if we do our jobs right in research and research operations and operations, there won't be these catastrophic space weather events, because we can mitigate, in terms of the power grids, these assets on Earth, protect life and property with different actions that we can have our stakeholders make. If we give enough warning, and accurate enough warning that they trust to take those actions, because sometimes there's an economic cost to making those decisions, and that's why we need better research that feeds into better operations, that feeds into better decisions.
Say again, Jim? So yeah, there's a tabletop exercise coming up where key stakeholders come together and play these scenarios through, establishing that common language and understanding what are those A to C's that we need to do in response to some of the space weather events out there. And that's run at APL. What's the date again, Steve? Yeah, May 8th and 9th. May 8th and 9th, right? So that'll be a really exciting exercise. being mindful of the time here, do we have any other comments about the previous question from the panel? We can take one very quick question, the most important question of the day. So who wants to ask it?
Way back up there on the right.
All right. And Alexa, identify herself.
Yeah, hi, this is Alexa. I'm Alexa Halford, not this is. I am a real person, unlike the Amazon device. I am the ionosphere, thermosphere, mesosphere lab chief at Goddard. So the nearest connection from Earth to space, right? Kind of region. And I want to say, Magdala, thanks for the wonderful discussion about the top-bottom kind of connection about space weather and your mention of Fitbits. And I know there was a review out between Apple and Garmin tracking devices for like running and things like that. And they mentioned the different GNSS constellations and the fact that they weren't always accurate every day. And I really wish they had put the dates that they had done those experiments, because it would have been great to see if space weather had affected that. So I was wondering if you had ideas about different user communities that we should be thinking about that we haven't really thought about. I know precision ag is a big one, but what are the other areas that you think the community hasn't really thought about that might be important for us to consider?
Aliens? Sorry. No, but seriously, this is the sort of thing that really excites me, right? Because, so I'm an astronomer, and I studied galaxy clusters far, far away, which had nothing to do with humans. And then here I am talking about space weather, which could take out technology and human civilization as we know it. But that's what got me interested in thinking about what other science data do we already have that we haven't even tapped, right? For instance, we know that we need radio observations of the sun, but we also have radio telescopes that are studying the universe far, far away. And sometimes they can't do their job because the ionosphere is changing so much, right? So what is noise for them is data for the space weather community. So some researcher's noise is some other researcher's data. How can we tap into that, right? You asked about a different set of users. We talked about aurora tourism, right? If all of you are going and if your cell phones are not working in a certain area, what does that tell you? Can that be useful data to the people who are studying space weather, who are doing the operational work? Can we have data assimilation for that kind of citizen science, big data kind of project, right? And then, 2040, we will have a presence on the moon. What data are we going to be getting without the atmosphere blocking all of the high energy radiation? Where will that data be? What can we use from there, from the moon, as well as from L1, L4, L5, the other side of the sun, right? So there are all of these things possible. Can we get together and sit and talk about that sometime, across the research agencies, across the industry, across the national security agencies, across the critical infrastructure operators? What are they seeing that we should know about? So that's the sort of thing. Alex, I don't know if that answered your question, but yeah, thank you for the question.
Thank you, Mangala. So we're going to have to finish here. We're 2 minutes over, so slap to me. So let's give a big round of applause for the panel. Fantastic panel. Thank you so much.